All right, students, we're continuing on with section 3.1, saying essential standards. I can understand quadratic functions, and given the graph of a quadratic function, I can identify axis of symmetry, vertex, and intercepts, direction of opening, up or down. Given a quadratic equation, I can graph it with labels and scales and the functions with all of its key features. Okay. If a quadratic function opens upward, that means the a value is greater than 0. The vertex is a minimum. So here is that situation right here. It's got a positive a value. The quadratic opens up, so the vertex is a minimum. If the quadratic function opens downward, that a value is going to be less than 0. Its vertex is a maximum. So here it is. It opens down, and so that vertex that we find, which is negative b over 2a, the x-coordinate of that at any rate, is going to be a maximum. Okay, here we go. My computer sounds like it's getting ready to take flight. Got lots of stuff going on. Okay, at any rate, determine whether the function has a minimum or maximum and explain. I'm on page 9. Here we go. All right, f of x equals minus 4 x squared plus 12x plus 18. So the first thing we needed to do to determine whether or not it has a minimum or a maximum. Well, our a value is a negative 4. So it's negative. A is less than 0. And so it's going to open downward, and we are going to have a maximum. Okay. But we got to be able to explain. This is where we lose points because we don't explain properly. So we have to actually explain. So we're going to, what is our answer? It has a maximum. And why? How do we know that it has a maximum? That is because f of x is a quadratic. Okay, it's a quadratic formula, and a is equal to minus 4, which is less than 0. Okay, this is how you justify and explain that the equation has a maximum. Why is it important that you actually tell me or tell your, me, that it is a quadratic and that this is justifying it and that it has a maximum? Well, because we could have y equals ax plus b, and who cares if a is negative or positive? A in that situation, that particular function does not have a min or a max. So you have to specify that it's actually a quadratic function. There's lots of different types of functions out there. Okay, it has a max because it's a quadratic and because a is negative 4, which is less than 0. You have now given an explanation of why it has a maximum. All right, continuing on. Find the minimum or the maximum value of the function and state the domain and range. Find the minimum or maximum value of the function, which is your output, your y value. Okay, so here, what do we have to do? Well, we got to find the vertex, which is negative b over 2a. That's the x-coordinate. What's negative b? It's negative 12 over 2 times negative 4. And that will simplify into a positive 12 over 8, because the negative cancel. I can simplify that to get 3/2. So now I need to find the y value that is associated with 3/2, and that gives me negative 4 times 3/2 squared plus 12 times 3/2 plus 18. So let's do some simplification. So 3/2 squared is 9 over 4 times 4. 4's cancel. So I get a negative 9 plus 12 divided by 2 is 6 times 3 is 18 plus 18, and I get a 27. So that is my vertex. My vertex is at 3/2. 27. What do they ask for? Find the minimum or maximum value of the function. The maximum, we said it had a maximum, happens when, what's the maximum value of the function? What's the output maximum value? 27. So the answer is 27. Okay, so that's the y value. That's the output of the function. The function's maximum at 27. Now, state the domain and range. So if I have a parabola, all the x's are possible. So domain, remember, is all my inputs or my x's, which are my x values. My range are all my outputs, which is my y values. And so domain is all real numbers, right? All reals is how we specify that. Now range, however, does not. It actually has a value. So because I have a maximum, y has to be less than or equal to 27. Okay, so there's my 3 answers to that question. Moving on, I see that I have a negative 1/5, which means that I have a negative a value. So I'm going to have it open downward, which means I have a maximum. That's not enough to answer the question. I have a maximum because g of x is a quadratic such that a, which is equal to minus 1/5, and that is less than 0. Therefore, I have a maximum. Okay. Now I got to go find what that maximum is. The first thing I need to do is find my x coordinate of the vertex, which is equal to negative b, which is negative 4 over 2 times negative 1/5. Okay. Which is equal to negative 4 over negative 2 over 5. Okay. I can multiply times the reciprocal, right? Multiply each of the items times the reciprocal, which is 5 over 2. Multiply this, 5 over 2. Yes, yes. I'm going to actually make it negative 5 over 2. And I will get my answer to be a positive 10. That's one way to do it. So let's look at the bottom of that. Negative 2/5 times a negative 5 over 2. That cancels. I get a positive 1 on the bottom. And then I just multiply the negative 4 times negative 5. That gives me a positive 10 divided, or 20 divided by 2. That's a 10. Okay. All right. Now we're going to find my y. Actually, output when x is 10. That's my y coordinate of the vertex, which is going to be located at my maximum. That's the maximum value of the function. So 10 negative 5, I'm sorry, negative 1/5. Come on, Deborah. Negative 1/5 times 10 squared plus 40 plus 1. All right, 10 squared, 100, divided by 5, 20. So negative 20 plus 40 plus 1. This is equal to 21. So this is my maximum value of function, because the function is your output. That's the maximum value of f of x. Okay, I'm not done yet. I got to give my domain. Domain for a quadratic, we have no limitation on my inputs. So is all reals. And my range, since it's a maximum, is y is less than or equal to 21. So there's the 3 things that they wanted. Moving on. First, notice a is a positive value. Therefore, I'm going to open up. I'm going to have a minimum. So how do I say that? I'm going to have a minimum. Because h of x, no, come back. Come back. Give it to me. Here we go. Oh, there we go. We're having all kinds of fun. We are really having an issue here. Okay, minimum, there it is. Minimum, because h of x is a quadratic and a is equal to 3/4, which is greater than 0. There is your justification for why we have a minimum. H of x, which is a function, is a quadratic function. A is 3/4, which is greater than 0. All right, moving on. We got to find what is the minimum value? We're trying to find the min or the max value of the function. Well, we first got to have to find our coordinate for our vertex, which is negative b over 2 times a, which is a negative 6 over 2 times 3/4. All right, we got some simplifications to do. We can cancel out the 2, that makes that 2. So I get minus 6 over 3/2. I can then multiply 3/2 times its reciprocal, correct? So that's 2/3, which then I have to multiply the top by its 2/3. So that equals negative 6 times 2 is 12, divided by 3 is 4, negative 4. Yep. Okay, moving on. I now need to find the y coordinate of that vertex, which will be my minimum. So I have to plug in negative 4 for x, which is equal to 3/4 times negative 4 squared, plus 6 times negative 4 is, well, let me just go ahead and write that, plus 6 times negative 4 plus 5. All right, 4 squared is 16, divided by 4 is 4, times 3 is 12, that's negative, minus 24. All right, why did I know why. This is not negative. Let's try that again. Negative 4 squared is a positive 16, divided by 4 gives me a positive 4, times 3 is a positive 12. 6 times negative 4 is a negative 24, and then I get plus 5. And all that added up together gives me negative 7. This is the minimum value that the function can have, okay? Because that's the y coordinate. So that, what is the value of a function? It's the output, okay? All right, we're not done. We have to give a domain and range. Domain for quadratic, all reals. We can have all possible x values. The range, what are my y values? What are my possible outputs? Well, if negative 7 is a minimum, that means that y has to be greater than or equal to 7. Okay, why don't you try one yourself? Pause the video. Okay, so welcome back. First thing hopefully you notice is that we have a negative 2. So since I have a negative 2, the parabola opens down, which means I have a maximum. So it's not good enough just to say it opens down. I will say it has a maximum. I have to justify that because y is a quadratic. I'm going to say y of x. I don't like that. Y is a quadratic and a equals negative 2, which is less than 0. You have now justified, you can probably be guaranteed, right? That's going to be one of your test questions that you have to answer. Okay, so next thing we're moving on, I need to find that maximum. Well, the first thing I do is I find my x coordinate of my vertex, which is negative b, so that's negative 12 divided by 2 times negative 2, which gives me a value of 3. Then I plug in 3 for y. So I'm just going to say y of 3 equals minus 2 times 3 squared plus 12 times 3 plus 1. So that gives me negative 18 plus 36 plus 1, which gives me a value of 19. This is my maximum value that the function can have. That's the y value. The function output, the max I can have is 19. Okay, so the domain is all reals. And then my range is y has to be less than or equal to 19, since that is a maximum. All right, moving on. Now I'm going to talk a little bit about this. When I get finished, I'm actually going to then pause it, go to a program that I have just recently acquired to actually show you the exact key function, okay? Your graphing calculator can also find relative, mins, and maximum. So let's learn how to use our graphing calculator. These functions are in the calculate mode. That will be in second function trace. You can see that little calculate on top of your trace button. Okay, unfortunately, your calculator is not very bright, believe it or not, and it's lazy. All right, so you have to answer 3 questions. Okay, it's also lazy, so it stops looking for it after it thinks it gets so close. So it can only report back 4 or 5 decimals. All right, so it's going to ask you to give it some information. You have to tell it left bound, so give it some idea of the left bound of it. You also have to tell it the right bound, and you have to give it a guess. And you got to be careful, because if you could imagine, you could have functions that look something like this, right? And if you're trying to find the maximum right here, you've got to make sure that you're providing, the closer you get, the better it is. Okay, and then you need to guess that number so you can have the calculator look for it. Because if you were to then, let's say, give, a guess of over here and give a value of your, your right bound, something that incorporated both max and mins, you could get the wrong answer. So be very careful on that. In addition to that, it has to be within the window. So what you have, you can zoom in and out of your graph. You have to have the actual calculator, the display, have the min or max that you're particularly looking for. Okay, so what do? How do you work this? The first thing you do is you take this function here, so y equals 0.25x squared plus 3x. You need to enter it into the calculator. You're going to go into y equals, okay? Ideally, there'd be nothing there. If there's leftover equations that you've had in there, you'll have to clear it out. You will then enter 0.25x squared plus 3x plus 1. Now you've got your equation in there. Then you're going to then go and hit second function, calculate, and you're going to find that you get this screen right here, okay? And since this particular equation has an a value of a 0.25, that's a positive number, so it's going to open upward, I'm going to have a minimum. So you have to tell it that I want number 3, which is a minimum. Now it's going to ask you your questions, left bound, right bound, and guess. You're going to actually have to enter it. Now you have 2 different ways to actually accomplish that. One, you can say to yourself, okay, I see that it's approximately around 6, so I'm just going to guess -8 and hit -8 and enter. The other option is to use your arrow keys and have it trace over and just get to the left side of the minimum and then hit enter. Doesn't matter what the number is, something close, and just hit enter. Then do the same for the right bound. So if we think it's around 6, I could enter in -2, or I could use the trace button and move to the right of the minimum, or right of the minimum. And then we need to guess. We need to actually guess. So you could once again use your arrow keys to get close to it and hit enter, or just guess the value. I kind of like the arrow keys, to be honest with you. And then it's actually going to do some calculations, and notice what it comes up with. Okay, it comes up with -6, and it has a whole bunch of decimal points with 1. So you can, this coordinate of this minimum is actually -6, -8. Okay, so don't get confused by this whole 1 at the end. That's terrible. Let's get rid of all that. Okay, it's -6, -8. Now, once again, in just a minute, I'm going to actually go to a different screen and I'll add on to this and I'll show you the keystrokes. But hopefully that makes sense. Now, why don't you try it yourself? And here is the quadratic. Use your calculator to find it. Okay, so welcome back. So first off, notice that they're actually asking the range of the quadratic function. So what is this? This is a -3, so it opens downward, right? So it has a maximum, and the range is going to be less than or equal to whatever this maximum is, right? I don't know what it is, but hopefully you found it. So you would have to have done the same thing. You would have entered in the equation going into, you would have gone up and hit y equals, entered in the equation negative 3x squared plus 6x plus 1. Then you would have gone to second function trace, which would have taken you to the calculate mode. But this time you would have had to select maximum, which is number 4. Then you would have had left bound, right bound, guess, and you would have had to actually provide those informations either by actually plugging in a number or using your trace function, right? Or your trace key and get to the left and to the right and then close to it and hit enter. And you would find that the maximum value, y is going to be less than or equal to 4. Okay, now I'm going to pause my video. I'm going to go and share my screen and I'll enter those into you for you if you'd like to see it actually worked out on a TI-84.